Hello everyone, welcome to our today's session. This is our CH230 topic, CH230 subject, coordination chemistry. This is our fifth lecture. It is quantum mechanics, Russell-Saunders coupling and term symbol. Okay, so we will discuss today what is Russell-Saunders coupling or term symbol. Here in this picture we can see one hydrogen atom. So hydrogen atom having only one electron rotating around that central core. Okay, so that moving electron will have angular momentum. That single electron is moving around a central core, and that moving electron will have angular momentum, and that angular momentum is denoted by symbol L. As we have discussed in our previous lecture, quantum numbers, there are 4 quantum numbers, so that L is equal to angular quantum number. So that moving electron shows angular momentum and it is denoted by symbol L. And electron also spin around its own axis. That electron, that hydrogen atom having a single electron, and that single electron also spin around its own axis, so it will have spin angular momentum. So that electron having spin angular momentum because of its spin around its own axis, and that spin angular momentum is S. Angular momentum denoted by L, and that spin angular momentum is denoted by symbol S. Okay, this is case where there is only one electron rotating around a central core. But in case there are more than one electrons which are rotating around a central nucleus, so in order to understand the energy state of atom, we will consider resultant angular momentum. Okay, so we will consider resultant angular momentum of all that electrons, which electrons will have, that all electrons rotating around central core, and that electrons will have angular momentum L. And in order to understand the energy state of that particular atom, we will consider resultant angular momentum, and there will be coupling of L and S, and each electron also spin around its own axis, so it will have spin angular momentum, and total resultant spin angular momentum of all electrons and their spins. And there will be coupling of L, means the angular momentum, and spin angular momentum. So there will be coupling of L and S. So this resultant angular momentum is shown by J. So what is resultant angular momentum? There will be coupling of L and S. L means angular momentum and S means spin angular momentum, and the resultant angular momentum, like coupling of L and S, is denoted by symbol J. And energy state of atom is shown by a term symbol. Okay, so there are different quantum numbers. First one is this is a magnetic quantum number, that is ml, which shows angular momentum, or L. The magnetic quantum number ml determines number of orbitals and their orientation within a subshell. So consequently, its value depends on the orbital angular momentum quantum number, that is L. This is magnetic quantum number or magnetic quantum number, which is denoted by ml. So it is ml is equal to L1, L2, L3, L4, etc. Okay. Then next one is the electron spin quantum number. We already discussed about electron spin quantum number in our, I think, third lecture. So in short, we will discuss the electron spin quantum number, that is ms. So value of ms. Okay, that it is designates the direction of electron spin. This quantum number designates the direction of electron spin and may have a spin plus 1 by 2 and minus 1 by 2. But spin plus 1 by 2 represented by upward arrow, or minus 1 by 2 represented by downward arrow. Okay, so this means that when ms is positive, the electron has an upward spin. When that ms or spin quantum number is positive, that electron has an upward spin. which can refer to as spin up. So that electron is referred to as spin up, or it shows upward arrow. And when it is negative, when that electron spin quantum number is -1 by 2 or negative, the electron has a downward spin, so it is spin down. And the significance of the electron spin quantum number is its determination of an atom's ability to generate a magnetic field or not. So it determines, it is the determination of atom's ability to generate a magnetic field or not. As we have seen, spin around its own axis, that electron spin around its own axis, so it will have spin angular momentum. Okay, so here it is ml and ms. Okay, there are three different types of couplings in Russell-Saunders coupling. There is Russell-Saunders couplings, which shows three different types of coupling. So what is that? First one is a spin-spin coupling. In first case, in Russell-Saunders coupling, the formula of Russell-Saunders coupling is like this term symbol, or Russell-Saunders coupling, that is 2s plus 1 Lj. Okay, so L and J. So that is Russell-Saunders coupling. So there are three types of interaction. First one is a spin-spin coupling. Spin-spin coupling means resultant spin angular momentum, that is spin-spin coupling. Then next one is a orbital-orbital coupling, and third one is a spin-orbital coupling. As we have seen, what is meaning of spin-spin coupling? Spin-spin coupling, it is 2s plus 1. The next one is a orbital-orbital coupling, is L, and there are different values of L. And third type of coupling is spin and orbital coupling. That coupling is L and S coupling. There will be coupling of L and S. LS means L is angular momentum and S is spin angular momentum. So there is angular momentum and spin angular momentum. There will be coupling of L and S, and this resultant coupling of L and S, or angular momentum or spin angular momentum, is denoted by symbol J, and that type of coupling is spin orbital coupling. So there are three different couplings. First one is a spin-spin coupling, that is 2s plus 1. Second coupling is orbital-orbital coupling, which is denoted by symbol L. And third one is spin and orbital coupling, that is L and S coupling, which is denoted by symbol J. Okay, so important coupling, this one, first priority goes to that spin-spin coupling, then orbital-orbital coupling, and last one is a spin orbital coupling. That spin orbital coupling is only that type of coupling is considered when atomic number of element is more than 30. Okay, so there are two main types of coupling in Russell-Saunders terms or RS terms. So Russell-Saunders or RS, that is LS coupling, and last one is a JJ coupling. First one is a LS type of coupling, and last one is a JJ type of coupling or JJ coupling. So what is JJ coupling or RS coupling, we will discuss. Okay, then first spin-spin coupling. So what is spin-spin coupling? S is the total spin quantum number. In that there is a coupling like spin-spin coupling, and that S, capital S, is the total spin quantum number, means resultant spin-spin coupling. So the total spin quantum number is capital S, and it is 2s plus 1 is the spin multiplicity, which represents the number of possible states of J for given L and S. Okay, given L and S, provided that L is greater than or equal to S, and if L is less than S, the maximum number of possible J is 2L plus 1. So this is spin angular momentum, or the coupling of spin angular momentum, or resultant coupling of spin angular momentum. Okay, so this is easily proven by that spin coupling. Okay, so next one is a L value. So what is L value? L value is angular momentum. So we will discuss that L value. L is the total orbital quantum number in spectroscopic notation. Okay, and last type of coupling is spin orbital coupling. First one is a spin spin coupling, that is 2s plus 1. Second is a orbital orbital coupling, that is L, capital L. It is the total orbital quantum number in spectroscopic notation. And third one is a spin orbital coupling. Last one is a spin orbital coupling. So that coupling is L and S coupling. This is easily proven by using J max is equal to L plus S and J minimum is equal to L minus S. So what is J max and what is J minimum? When orbital is less than half filled, then we can use J minimum value, J minimum value, and for that we will use L minus S. And if that orbital is more than half filled, okay, there are number of electrons are more than half filled in that orbital, so that orbital is J max and the J value is L plus S. So J is the total angular momentum quantum number. So that J is total angular momentum quantum number, and that is coupling of L and S. When orbital is less than half filled, it is L minus S, and if that J is L minus S, and if orbital is more than half filled, then J is equal to L plus S. Okay. So there are numbers. L is the total orbital quantum number in spectroscopic notation, and it is denoted by S is equal to 0, P is equal to 1, D is equal to 2, F is equal to 3, G is equal to 4, H is equal to 5, I is equal to 6, and K is equal to 7. S, P, D, F, G, H. S is equal to 0, start from 0, P is equal to 1, D is equal to 2, F is equal to 3. So L values are L values for S orbital is 0, L value for P or for L value, if L value is 0, then it is S orbital. If L value is equal to 1, then it is P orbital. Okay, if L value is 2, then it is F orbital. If G orbital is there, then L value is equal to 3, and if H orbital is there, then L value is 4. So here are some L values or total quantum numbers in spectroscopic notations. So what is term symbols? Okay, in quantum mechanics, the term symbol is an abbreviated description of the total angular momentum or quantum numbers in a multi-electron atoms. Okay, even single electron can be described by a term symbol. There are multi-electrons also used for term symbols, and even single electron can be described by a term symbol. So each energy level of an atom with a given electron configuration is described by not only the electron configuration but also its own term symbols. As the energy level also depends on the total angular momentum including spin. Okay, so that energy level also depends on the total angular momentum and including its spin. So the usual atomic term symbols assumes LS coupling, that is LS coupling or Russell-Sounder coupling, and it is also known as Russell-Saunders coupling or spin orbital coupling. Okay, so it is spin orbital coupling, LS coupling or Russell-Sounder coupling. Why it is LS coupling? Russell-Sounder spin orbital means there is a coupling between spin angular momentum and orbital angular momentum, that is L, and spin angular momentum is S. That's why it is spin orbital coupling or J type of coupling, that is the J type of coupling. So it is LS coupling. It is also known as LS coupling, Russell-Sounder coupling, RS terms or spin orbital coupling. Okay. So the ground state term symbol is predicted by Hund's rule. There are 3 different rules which are used to predict the ground state term or term symbol. Okay. So what is term symbols or Russell-Sounder terms? And there are 3 different rules or basic rules we used to determine term symbols. First one, what are term symbols? In quantum mechanics, the proper definition of term symbol is that in quantum mechanics, the term symbol is an abbreviated description of total angular momentum quantum numbers in a multi-electron atom. Okay, so this is definition of term symbols, and to describe the electron configuration in an atom, we can use that Russell-Sounder term. That term is in this picture we can see 2s plus 1 is spin-spin type of coupling, L is orbital-orbital type of coupling, and that J is spin orbital type of coupling, or there is a coupling of L and S is J. If orbital is more than half filled, then L plus S, and if orbital is less than half filled, then take L minus S. Okay, J value is L minus S. So there are three rules to determine the term symbols, or not term symbols, to ground state term. Okay, the lowest energy term will be one with highest multiplicity. This 2s plus 1 is a multiplicity. This superscript indicates its multiplicity, that L is orbital-orbital coupling and that J is subscript is L and S coupling. Okay, so the lowest energy term will be one with highest multiplicity is one with maximum number of electrons. Okay, if there are different terms like doublet P, singlet P, triplet P, so the lowest energy term will be one with highest multiplicity. If multiplicity means 2s plus value is high, then we can use that term as a ground state. Okay, this is first rule. Then second rule is, if there are more than one term of same multiplicity, then term with largest value of L will be the ground state. If there are two states like doublet P and doublet D, then ground state must be doublet D. Okay, and third rule is, for half filled or less than half filled term, ground state term is of lowest J value. Okay, so for half filled or less than half filled term, ground state term is lowest J value, as we have already discussed. L plus S and L minus S. If orbital is half filled or less than half filled, then we can use L minus S, or we have to use L minus S. That's why ground state term is of lowest J value. There are two different values of J. First one is L plus S when orbital is more than half filled, and second value is L minus S when orbital is less than half filled. So this is third rule. We can apply this rule to determine the ground term. Okay, so in this topic we have discussed about term symbols, then Russell sounder, that is Russell sounder terms, then angular momentum and spin angular momentum, and the coupling, LS type of coupling, and J values, resultant angular momentum also. Okay, so in next topic we will discuss about how to calculate ground state term or Russell sounder term. Okay, thank you.